Hi, and welcome to this video series by Hubs on surface finishes. Today we are taking a look at powder coating. How does it work? What are the benefits and limitations? You'll find the answers to these questions and more in this video. What is powder coating? Powder coating is a process in which powder, consisting of very fine ground particles of pigment and resin, are electrically charged and sprayed onto parts. This adds a thin layer of polymer on the surface of the part. The parts that are being coated are grounded so that the charged particles that are being sprayed adhere to the part until melted and fused into a solid coating in a curing oven. There are three main categories of powder coatings: thermosets, thermoplastics, and UV curable powder coatings. Powder coating can be applied to almost every material, with metal being the most common. Most powder coated finishes are between 2 and 3 mils thick, or between 0.05 mm and 0.08 mm. Overall, powder coating is known for being a strong, durable, corrosion-resistant and cost-efficient finish. Next, let's talk about appearance. Colors in powder coating are a combination of chemical pigments mixed with the base formulation. The pigment itself isn't enough to describe the color of a coating, as variables like gloss and texture influence the appearance as well. In powder coating, there are different levels of gloss, going from matte to high gloss, and textures that can be added to the part. When it comes to textures, some include standard finish, wrinkles, sand texture, and hammer texture. Moving on, how does powder coating work? The powder coating process consists of three basic steps: pre-treatment, powder application, and curing. Let's discuss each step in a little more detail. Step 1. The pre-treatment. First, the parts go through a chemical treatment in which the parts are degreased and cleaned. This is done using acidic, alkaline, or neutral cleaning agent. Second, there is mechanical treatment. During this process, sand or shot blasting can be used to create an anchor pattern on the part. This is done to improve the adhesion of the powder coating to the substrate. Third, parts are dried in a low-temperature dry-off oven. Lastly, the parts are rinsed to remove any chemicals used to clean and treat the surface. This is done in a deep tank or wash line with neutralized water and a slightly acidic solution to seal the surface. Now, step 2. The powder application. There are three different types of powder application: fluidized bed coating, electrostatic fluidized bed coating, and electrostatic spray deposition. Because electrostatic spray deposition is the most used application method, we'll focus on ESD. During this process, an electrostatic spray gun is used to spray dry powder on the grounded part. The tip of the gun, through an ionized electrostatic field, charges the powder particles as they are sprayed out of the gun and onto the part. Because the powder particles are charged, they are attracted to and wrapped around the grounded part. Step 3. Curing. After the parts have been sprayed, they are cured in a curing oven. The oven will reach a temperature of between 150 to 200 degrees Celsius, resulting in the melting of powder particles into a unified film. The parts are then cooled to create a hard coating. Moving on to benefits and limitations of powder coating. Starting with the benefits. First, durability and longevity. Powder coating is a very durable finish, especially compared to liquid coatings. It's highly resistant to wear and tear, and is therefore often applied in products that are used outdoors, like cars and benches. For instance, it's super resistant to scratching, chipping, and fading, making it a finish that will make your parts or products stay intact and look good over a long period of time. Second, efficiency, or time and money savings. Powder coating is less time-consuming and less costly than most liquid paint applications. That is, the startup costs might be higher but are more economical in the long run compared to other painting methods. This is mainly because it requires less manual labor, the process requires less raw material and equipment. And on top of that, the powder coating process itself is faster, as powder is applied, immediately cured within about 20 minutes and then cooled. Third, environmental and health safety. Powder coating does not produce damaging fumes or pollutants. This is a big contrast in relation to solvent-based paint, which are usually quite harmful and contain a lot of VOCs. Besides that, it generates less product waste and lower finishing line emissions. Now for the disadvantages. First, with powder coating it's difficult to produce thin, even coatings. The process is great for making even thick coatings, but it's harder to create the same result with a thin coating. Second, materials. Because the powder coating process requires curing in an oven, the materials that are used need to be able to withstand the curing temperatures. Third, startup costs. The startup costs of powder coating are greater than for most liquid coatings. But as mentioned before, it's more cost-efficient in the long run. Lastly, we'll go over DFM considerations. Hanging and jig marks. Because powder coating involves hanging parts on a rack, there will be marks on the part where the powder couldn't reach. This means that you should always add a technical drawing if there are areas on your part where you can't accept marks. Masking. Powder coating provides a thick coating that can cause parts to be out of tolerance. Masking is important for any critical to function surfaces like threaded and reamed holes. Always indicate in your CAD file whether you want specific areas to be masked or plaqued. Tolerances. Tolerances should be met before the coating finish. We recommend that you ask for clarification about masking as needed. With that, we have come to the end of the video on powder coating. We hope you enjoyed it and learned something new. Please don't forget to like and subscribe, it really helps the channel. See you in the next video.